Hello class, this is Mr. Lehman. I want to talk to you today about calculating the molar mass and also mole conversions. Very important concepts as we progress through the second half of the year. So first thing, the concept of the mole, I know we talked about in class. 1 mole of something, chemists tend to leave the E off to say MOL, so 1 mole of something is equal to 6.02 times 10 to the 23rd of that object. So if you have 1 mole of copper, that means you have 6.02 times 10 to the 23rd atoms of copper. If you have 1 mole of water, then you would have 6.02 times 10 to the 23rd molecules of water. So 1 mole of an object is equal to 6.02 times 10 to the 23rd. You might be wondering, well, how did we come up with that number? It was Amadeo Avogadro who came up with how many atoms or how many of an object it takes to convert atomic mass units, AMUs, into grams. So a quick review of that, if we look at something like copper, 1 atom of copper is equal to 63.546 AMUs on average. Really tiny number. If you have 602 sextillion copper atoms and you put those all on the scale, they would weigh the same number, but in the units of grams, a measurable quantity based on the equipment that we have in the room. Now our scales only go up to the hundredths place, and so what we're going to do from here on out is we're going to round the masses from the periodic table to the nearest hundredth. So we would round copper's molar mass to 63.55 grams. Remember, if the thousandths place is 5 or higher, then we'll round the hundredths place up 1. If the thousandths place is 4 or lower, then we'll just drop it. So if you look at the periodic table, the bottom number will tell you the molar mass for elements. There are some exceptions to the rule. There's 7 elements that are diatomic. That means in nature, when they're found in a pure form, they're going to be found in pairs. So hydrogen is diatomic, nitrogen is diatomic, oxygen is found in pairs, fluorine is found in pairs, and then within the same family we have chlorine found in pairs, we have bromines found in pairs, and iodine's found in pairs. So these 7 on the periodic table make up what we call the 7 diatomic elements. All the other elements are found as single atoms, not as pairs. So the next step in our process here is, well, if we have 1 mole of copper, it weighs 63.55 grams. What happens if we have 1 mole of a compound? Let's say we have 1 mole of calcium chloride. How much would it weigh? How many grams would it weigh? How much would you have to weigh out to have a mole? Or 6.02 times 10 to the 23rd formula units. So remember, ionic compounds, metal nonmetals, form crystals. The simplest ratio of ions in a crystal is called the formula unit. And so we look here, calcium, 40.078, that rounds up 40.08 grams per mole. Chlorine is 35.45 grams per mole. Sorry, I drew the line right through the number so you can't see it. So we're going to pull those numbers. And the way I like to set this problem up is I say, alright, calcium, how many of them do I have in the formula? In one formula unit, I have 1 calcium atom. And the periodic table, the bottom number says it weighs 40.08 grams per mole. So 1 times the number is that number. That's nice and easy. Cl, I got 2 Cl ions per formula unit. So I have to compensate for that. I have to double the mass of 1 chlorine since I had 2 chlorines in the formula. And that, I'm sorry, I had a typo here. That should be calcium. Sorry about that. Just thinking ahead. Here's chlorine. So if we add it up, we get 110.98 grams per mole for 602 sextillion formula units of calcium chloride. So the units for molar mass are grams per mole. Alright, if we look here at another one, let's do glucose, simple sugar, C6H12O6. I like to set it up, list the elements as they appear in the formula, figure out how many of each element, how many atoms of each element are present per molecule. So in one molecule, 6 carbons, 12 hydrogens, 6 oxygens. So if we have a mole of molecules, how much would it weigh? Well, we look at the periodic table, carbon is 12.01 grams per mole, but we have 6 per molecule, so we need to multiply it by 6. Hydrogen, we have 12 hydrogens. Each one is 1.01 grams per mole, so we times it by 12 since there's 12 of them in the formula. Oxygen is 16.00 grams per mole. We have 6 of them, so multiply it by 6, which is 96 grams of oxygen. Get the sum. Carry the 1. 8, 9. 9 plus 9 is 18. Units will be 180.18 grams per mole of glucose. Alright, we'll do one more. Since I'm thinking of it, if you have something like calcium phosphate. Oops. Having a rough day here. At least I'm catching my mistakes. Calcium is +2. Phosphate is -3. And so that would give you the formula unit. We need 3 plus 2 calciums to react, to combine with 2 -3 phosphates so that we get +6 and -6. And so from here, let's figure out the formula mass, the mass of 1 mole of this ionic compound. We have 3 calciums, 1 phosphorus, but then there's 2 of it. So everything in parentheses we double, so we multiply by the 2. So we have 2 P's, 4 oxygens times 2, 8 oxygens. We already determined that calcium is 40.08 grams per mole. So we have 120.24 grams of calcium. Phosphorus, let me check the periodic table, is 30.97 grams. So that would give us 61.94 grams and 2 phosphorus, and then 16.00 grams for oxygen times 8. So we have 3264, double 64, 128 grams of oxygen. Added together, we got 8, 11, carry the 1, 2 and 8, 0, carry the 1, 3, 9, 11, carry the 1. And so we get calcium phosphate is 310.18 grams per mole. So that's how we calculate the molar mass, the mass of a compound. Alright, so what we're going to do next, I'm going to stop here. This has run longer than I thought it would, but that's alright. The next tutorial will get into mole conversions. See you then.